So earthquake occurrence. We've talked about how earthquakes are happening all the time, all around Earth. But let's talk about really where on Earth. Okay, so earthquakes are common. They're most common at plate boundaries. If we look at this map of Earth, where those blue lines are showing tectonic plate boundaries and the red dots are showing the earthquake zone, you can see that earthquakes most often occur along plate boundaries. Okay? At divergent plate boundaries, such as the mid-ocean ridge, right, these earthquakes are pretty shallow, meaning they're less than 10 kilometers deep and they have low energy, but they're still there. At divergent plate boundaries on land, once again, they're fairly shallow, they're fairly low energy, but they're still there. So divergent plate boundaries, they have earthquakes, but they're shallow and they have low energy, low magnitude. Convergent plate boundaries, on the other hand, are a different story. So convergent plate boundaries, this is where earthquakes can be shallow, intermediate, or deep. Those that are shallow occur when the subducting slab or the subducting tectonic plate starts to bend. And where that plate starts to bend is going to create cracks in the surface of the Earth, cracks in that plate, and that's going to create earthquakes. And also right around here, you can get mega thrust earthquakes, and these are the ones that are linked to tsunamis. And we'll talk about how earthquakes cause tsunamis a little bit later on. So you can also get deeper earthquakes at convergent plate boundaries. And this is where subducting plates dive deep down into the mantle. And wherever that subducting plate is coming into contact with the overriding plate, right, you're creating friction, you're creating tension, and you're also going to have earthquakes there. So at convergent plate boundaries, we've talked about the earthquakes that happen right where those two plates collide, but there's also earthquakes further away from the plate boundary, still near the plate boundary, but a little bit further away. And this is because you're creating compressional forces all around that plate boundary, right? This is one of the reasons that mountains are formed at convergent plate boundaries, because of all that compressional stress pushing things together. So you're also going to get earthquakes around where those mountains are being built. And we call mountain building orogeny or orogenic uplift. All right, so we've talked about divergent boundaries create shallow, small earthquakes. Convergent boundaries can have shallow and deep earthquakes that can be huge. Now we're going to talk about transform plate boundaries. Transport plate boundaries, right? That's where Earth's crust is just moving not up or down, just side by side. A good example of this is the San Andreas Fault. It's the one that cuts through Western California, and it's where the Pacific Ocean plate is moving to the north and the North American plate is moving to the south relatively. And we get huge earthquakes along this transform fault. For example, in 1906, there was a 7.9 magnitude earthquake that completely destroyed San Francisco. Almost all of San Francisco had to be rebuilt after that earthquake. So because the San Andreas Fault runs through California, California is one of the most seismically active places in the US and on Earth. So there have been huge earthquakes in the past, and there will definitely be huge earthquakes in the future for Western California. So we've talked about how earthquakes occur at plate boundaries, but that's not the only place. We do have earthquakes here in Georgia, right? About 5% of earthquakes don't occur at modern plate boundaries. In many places, they occur anywhere where there's weakness in the crust related to previous plate boundaries or previous mountain building orogenic events or previous rifting in the continents, right? Any sort of previous tectonics, you can get faults that create earthquakes within or in between the continents away from these plate boundaries.